Hello, everybody. Welcome back. We are continuing with Chapter 9 notes on atmosphere and severe weather, but we're actually going to take a little bit of a break from the notes in this video and just kind of mark up a diagram that you actually should have in your notes. So we're not going to be writing a whole lot, but we're going to be doing, we're going to be drawing some arrows and labeling some things, and it'll probably be helpful if you have at least two different colored pencils, probably one red and one blue, or something something close to that. Some warm color and some cool color. It doesn't need to be red and blue. It could be purple and orange, whatever. Any colors that indicate warm and cold. So what we're going to do is we're going to look at how location on the Earth, be it at the equator or at about 30 degrees north latitude, or 60 degrees north latitude, or 90 degrees latitude, which is the North Pole, how that experiences air circulation around the world. One thing I will say is that what you see right here is probably a little bit more zoomed in from what you have. We're mostly just going to focus on the northern hemisphere. Don't worry about the southern hemisphere. For now, we're just going to focus on the equator and up. Okay? So, Earth's wind patterns. What ultimately drives the Earth's wind patterns? Well, all processes, we've talked about this already, all processes ultimately come from the sun, right? And so just imagine the sun being way over here. I'm drawing it, I'm not even sure if you can see that. I'm drawing a yellow thing way over here on the side. And that's supposed to represent the sun way, way, way far away. Okay, and rays of energy come from the sun. And where do they strike the Earth most directly? Where is the Earth heated the most efficiently? Well, it's at the equator, right? That's why we say the equator is hot. We live somewhere up here, right? We say we go down south. As we move south towards the equator, it gets warmer. And that's because the equator gets most direct rays right from the sun. So we're going to say this is what drives, or at least one of the things that really drives the circulation around the world. Okay, so at the equator, what happens? Well, the sun heats the land, and the land gets hot, and it causes the air to get hot. So the air at the equator tends to rise up. So that's what we're going to do right here. I'm going to draw some arrows indicating air at the equator rising up. Now you may say, well, that doesn't look like up to me. That looks like sideways. But yeah, remember that anybody standing on the Earth, say somebody standing at right near the equator, right there, all right, they're standing kind of on the side of the Earth. So anything that way is up to them. So air is rising up. But what happens when air rises up? Well, it cools, right? As it goes through the atmosphere, it cools and it condenses, especially, well, the water vapor in the air condenses. And so as it does that rising air that condenses is going to rain down, and it's going to cause there to be a lot of precipitation at the equator. Oh, you know what? You probably do well to have some other colors as well. Well, you don't need these other colors necessarily, but I'm going to add some green in here. And what I was going to say was, one result of this is that at the equator, you see a belt of green all around the Earth. Well, or at least wherever there's land. You see green at the equator. You see lush tropical rainforests. Why is that? That's because the air is rising up because it's being heated by the sun. As it rises up, it cools and condenses, and it rains down, and it makes a belt of green all along the Earth. Look at the Earth. You'll see wherever you're at the equator, it's going to be very, very green. Okay? Well, this air can't keep rising up forever, and what it winds up doing is that it rises up and it has to move towards the poles. All right, so it's cooled here a little bit so that it condenses, and it moves towards the poles. Move towards that pole and towards the South Pole as well, but we're not going to worry about that. And let's just stop there for a second. All right, we're gonna leave the equator for a second, and we're going to move to the North Pole now. All right, so we kind of focused on the equator. The heat from the sun's heating of the equator causes air to rise up. But now let's look at the North Pole. All right. Well, the North Pole doesn't get very direct rays from the sun, does it? I mean, it gets rays from the sun, but they are not very direct, and they're kind of say, kind of glancing. And so that's why the North Pole is cold, because the land is curving away from the direct rays from the sun. So it's cold at the North Pole. I think you probably knew that. All right. And so what does cold air want to do? Cold air is going to want to sink. Cold air wants to sink and move down towards the land. All right, not rise up. In fact, I'm going to erase that for a second. It's not going to want to rise up. It wants to sink. So if rising air cools and condenses, what does sinking air do? What sinking air does is that it kind of warms up and dries out. So I'm going to draw this arrow one more time. Okay, cold air at the poles sinks down, and what happens is it warms up slightly. I mean, it's not going to be balmy at the North Pole. You know that. In fact, I'll write that in red. Sorry. It warms up slightly and dries out. Because if air cools and condenses when it rises, it warms and dries out when it sinks, and that's exactly what's happening right here. Okay, so I've got an air mass sinking down. It's still not going to be warm air, but it's going to be relatively warmer than it was, and it's going to be become drier. After all, if you dry your hair, don't you dry it with warm air? So this air is going to warm up and dry out, which, by the way, is why at the North Pole it is very dry. You think, well, there's all that ice and snow around. Yeah, but the air itself is very dry at the North Pole. And that's also why, if you're outside in the cold weather, your lips get chapped and your skin gets dry, because the air is very, very dry. All right, so this air right here can't sink down to the earth forever. What's it going to wind up doing? Well, it's going to start moving across the surface of the earth. It's going to be moving down towards the equator. And it'll do that on this side too, but we're just going to worry about one side for now. All right? Do you see the difference right here? At the equator, air rises up, cools and condenses, and moves towards the poles. At the North Pole, air is cold, it sinks down, dries out, and then moves towards the equator. All right. Well, let's go back now to the equator now. All right, so this air is rising up and moving towards the poles. Well, it can't move towards the poles forever. Why not? Because as it moves towards the poles, it gets colder. All right, and colder air is going to sink. So this air gets, well, part of the way between the equator and the poles right here. All right, and then it starts to sink down. It sinks down towards the Earth's surface. And this is about, well, I'll write it over on the far side here. This is about 30 degrees latitude. The equator, you probably know, is 0 degrees latitude. This line right here is 60 degrees latitude, and the North Pole itself is 90 degrees latitude. So at about 30 degrees north latitude, this air that rose at the equator starts sinking back down. All right, because why? Well, because it's moving away from the equator. It's getting colder. So it sinks back down right here. But you know what happens to air when it sinks, right? It warms up a little bit because it's moving down in the atmosphere, and it dries out. And so as this air sinks right here, you're going to have a dry area. In fact, all along 30 degrees latitude, all along here, it's going to be very, very dry. What I'm going to do is I'm going to draw that as some yellow right here to indicate deserts. All the greatest deserts in the world exist at about 30 degrees north latitude or 30 degrees south latitude. I mean, there's more land in the northern hemisphere, so you'll see them more in the northern hemisphere. But as air is sinking back down, it dries out, leaving great deserts at 30 degrees north latitude. Okay, well, let's move back to the North Pole again. This air is sinking down, right, moving across Earth's surface. But as it moves from the North Pole down towards the equator, what happens? Well, it starts to get warmer. And as you know, warm air, at least air that's warmer than it was, tends to rise up. So at about 60 degrees north latitude, this air is going to want to rise up right here. Well, what happens to air when it rises up? It cools. It condenses into clouds. All right, so at about 60 degrees north and south latitude, this is going to be an area where great storms take place. Now, most people don't live this high. of latitude, but you might in the North Atlantic or the North Pacific, there are tremendous storms that take place because air that is moving along Earth's surface is now rising up right here. Do you see what's happening here? We have kind of a counterclockwise motion here between the equator and 30 degrees north latitude, and here we have a clockwise rotation. I won't really say rotation, but I mean down across Earth's surface and then up, up, circulating towards the poles and sinking back down right here. So what's going to really happen here is that we're going to have 3 cells of rotation. All right, so this air sinking back down, it can't sink back down forever. It's got to, the land is right there, so it's got to go 2 ways. It's going to go either towards the equator or towards the poles, and that's exactly what's going to happen. So let's see, turn this into red right here. I keep switching colors, so it takes me a second. So that moves towards the poles, or towards the equator, and that moves towards the poles. Likewise, this air rising up right here that cools and condenses isn't going to rise up forever, but it's going to split and it's going to go towards the equator or towards the North Pole. And so it's going to either go that way or go that way right there. Okay? So we've created really 3 cells of circulation. Up, over, down, across. Up, over, down, across. And by the way, since we live on Earth's surface, this is what people between 30 degrees and 0 degrees latitude would experience. Air trying to move from the north to the south. Here we have down, over, up, across. Here we have down, over, up, across, etc. So as you live at the Earth's surface right here, you're going to be experiencing whatever these red arrows are right here in terms of wind direction. All right? So, what do we call these areas here where it's at the equator, or 30 degrees north latitude, or 60 degrees north latitude, or the North Pole? Well, at the equator, what's happening to the air? Well, it's leaving the area, right? It's rising up. It's rising up away from the equator right there. You might say it's diverging or it's moving away. So what this means is, at the equator, this is a low pressure zone, right? It's a low pressure zone because the air is kind of leaving it. Okay, so we call this, I'll write this in black right here, the equatorial low pressure zone. And really low pressure is caused by air wanting to rise up. Now, contrast that against 30 degrees latitude right here. What's happening? Well, air is sinking down into this area right here where people live at 30 degrees latitude. Air is being crammed into one area. It's sinking down. It's going here and here and sinking down into towards the earth. And so air is being crammed here. So that creates a high pressure area. High pressure air is being, oops, I don't want to do that. Well, yeah, I'll do that. I'll call high pressure. I'll make high pressure blue. I'll make that red actually. I'll make low pressure red right there. Because warm air that wants to rise up and vacate the area creates a low pressure area. On the other hand, high pressure cold air sinking down, cramming into an area makes it high pressure. So we call this area at 30 degrees north and south latitude, we call this the subtropical, subtropical, can't write today, tropical high pressure zone. Subtropical high, all around the Earth, 30 degrees north latitude. All around the equator, it's zero. It's a low pressure because air is rising up and vacating the area. All along 30 degrees latitude is high pressure because air is sinking back down towards the Earth's surface. All right, at 60 degrees north latitude, look, air is vacating the area. It is rising up. It's getting out of there. All right, so that makes for low pressure. Like I said before, low pressure air tends to be warm, or warm air tends to create low pressure. And so, because it's rising up and vacating the area, so we call this area the subpolar low pressure zone, all around 60 degrees north latitude. And finally, well, the North Pole is really just a point, really, but right at the North Pole, where air is sinking down. Air is being crammed into that area right there because it's sinking down from higher altitudes. What do we call that? We call that the polar high pressure zone. H-I-G-H. Sorry about that. Polar high right there. So we've got the polar high, the subpolar low, and I'll put a blue H right there. So it's really high pressure right here because air is sinking down, cramming into that area. The polar high, the subpolar low all along here, the subtropical high at 30 degrees around the world, and the equatorial low all at the equator. There are certain wind names that exist between each of these latitudes because, look, air is moving from north to south, from south to north, from north to south. But for the time being, we're going to leave those blank for now. We may talk about them a little later, but they don't really, they may not be as important as in other classes that I've done. So for the time being, just know your pressure zones, low, and high, what the names of them are, and what actually causes them. Ultimately, everything is caused by the heating from the sun. So that's it for now. Thanks for listening. Thanks for following along, and I'll see you on the next one.